So very good morning to all members present here. Today we are in the day 3 lecture series in design of experiments. We are going to see about orthogonal array design. So let us see the principles and guidelines of orthogonal array design in the succeeding slides. What are the basic objectives of orthogonal array in design of experiments? The primary objective is to address the broad range of combination of input variable with minimal effort, ensuring that all significant interactions are accounted for. Using minimum number of experiment, we can able to find out the significance of the output response variable for various multifactorial design. Orthogonal array helps to improve the efficient test case of the design, and moreover it tries to improve the comprehensive test coverage. It will try to identify the most important key factors in the experiment, and based on that finally it will maximize the productivity of the parameters by further optimization. So these are the basic objectives of orthogonal array. In continuation to that, we will see what is meant by an orthogonal array as per the field of design of experiments. Orthogonal array is used to efficiently plan the experimental design to study the various effect of multiple factors on a common outcome. These arrays ensures that the factors are independent of each other, allowing for more accurate and reliable analysis. Let us see an example with the supporting definition. Consider a microprocessor company, an electronics component manufacturing company, having a difficulty with its current silicon processor that are made on a large die cut into pieces, and each one is tested to match the specifications. The company has requested that you run an experiment to increase the processor yield. The factors that affect the processor yield are temperature, pressure, doping amount, and deposition rate. So these are the multiple factors which are independent with respect to each other. So you want to find out what is the effect of processor yield. That is the output response variable. We have to quantify it. And they have given the input variable data to determine Taguchi experimental design orthogonal array. Operating conditions for each parameter level are listed below. So there are three different set of temperature, pressure, and then the doping effect and deposition rate. So under each factor, the number of levels are considered to be 3. So conduct 3 trials of each experiments based on the data collected and compute the signal to noise ratio for each experiment for the target value case. Create a response chart and determine which parameters have the highest and lowest effect on the processor yield. So we have to conduct 3 trials for each experiment and find out the signal to noise ratio for every parameters Then determine which parameter is considered to have highest and lowest impact with respect to the processor yield. So this is what we want to examine finally. So here the experimental design has been done using L9 orthogonal array. The temperature, pressure, doping effect, deposition rate are represented in such a way, and they have conducted three different trials of experiment, and the mean average value has been taken from the three trials. Using L9 orthogonal array, so the filled-in orthogonal array look like this. So they have taken the most important factor, temperature, pressure, doping rate, and deposition rate. So for this, we need to find out the signal to noise ratio. This table is created for calculating the signal to noise ratio for every factor. Let us see sample calculation for factor B for pressure. How to calculate the signal to noise ratio. Take experiment number 1 in pressure. Then experiment number 4 and experiment number 7. See 147. Take average divided by 3. You can able to find out what is the signal to noise ratio for B1. Similarly for B2, B3, for every levels of pressure, we can able to find out the signal to noise ratio under each experiment number. It's a sample calculation which is represented here for your kind reference. Likewise for temperature, everything we have to find out the signal to noise ratio. Now find out the range. How to determine the range? The effect of this factor is calculated by determining the range. So find out the maximum and minimum value from the signal to noise ratio of factor B. So 23 minus 19.8. So you can find out the range 3.2 delta. So likewise for every factor we have to find out the range, temperature, doping effect, deposition rate. So this table tells about the grouping of highest and the lowest, the factor which has a significant difference level with respect to the processor yield. So from this it is noted that the deposition rate has the largest effect on the processor yield and the temperature has very lowest effect on the processor yield. So rank them accordingly 1, 2, 3, 4 in such a way. So from this, what we conclude that in design of experiment, the orthogonal array is said to be the systematic experimentation process that ensures each level of factor to be tested with every other level of other factors for an equal number of time. And this allows for independent estimation of factor effects and efficient experimentation, making them valuable for reducing the number of experiments needed. And also we can able to balance the variance by controlling the error in the experimentation process. With this, I thank each and every one of you. We will meet in the next session. Once again, thank you all.